Hey guys, and welcome back to Learning-CrazyElectronics. In this video, we're going to be doing a tutorial on how to code our Raspberry Pi smart car so it can be controlled through a web application. So let's go into the video. First, you need to plug in your Raspberry Pi like I did. You can see at the bottom of my screen, I just got an image of my Raspberry Pi, as you can see, and I've just plugged it in, and you can go ahead and open your desktop like I did now. And now what we can do is go ahead and open a default page of our Thorny IDE, which is the default IDE of Raspberry Pi. And the language we're going to be using to code today is Python. Okay, so once you have a page of this opened, we can go ahead and start coding. So first, we need to import the rpi.gpio library because we need to access the GPIO pins. So let's go ahead and import that. To import it, all you need to type in is import rpi, the all caps GPIO, space as, space, and then you can go ahead and give your library a nickname. Let's just say we want our library to be GPIO because it's much easier to call it every time we need to call a function from the rpi.gpio library. And once you've got that done, we need to also import the library time because we're going to be using time, some functions from the time library as well. So import, all you need to type in is import space time. And once you do that, we can click enter, and that's all your libraries imported, and that's all the libraries you're going to be needing. We can go ahead and now write functions to set up, or just one function to set up our Raspberry Pi. Basically all the GPIO pins and access them all. To do that, all you need to type in is def space setup. I'm going to name my function setup. You can name it whatever you like. And under that function, all you need to type in is gpio.setMode, open brackets, and type in gpio.board, all caps, and close brackets. And once you do that, we can now declare our pins because we've now set up our GPIO board. To declare all your pins, all you need to type in is gpio.setup, open brackets, and declare whatever pin you're trying to set up. If you remember from our last tutorial, the pins we were using to set up were pin number 7, pin number 11, pin number 13, and pin number 15. So we can go ahead and declare those here. First, I'm going to declare pin number 7. So just type in 7, comma, and all you need to type in is gpio dot all caps OUT and close brackets. Now what we've done is set up the board. So we've made the GPIO board active. We declared our first pin, and what we've did is gpio.out because we sent a signal, and if we were to receive a signal, we would put in gpio.in. So we'll just copy this line of code and paste it 3 more times. And once you do that, you can go ahead and change your pin number. So let me just copy this one more time to just paste it. And once you do that, you can go ahead and change your pin numbers to whatever pins you're using. I'm using pin number 13, pin number 15, pin number 11, like I said, and 7. So once you declare all your pins and set them up, that's your setup function ready. And you can go into controlling our car now. Now before we go into controlling our car, we need to learn a pretty important concept. So let's go ahead and learn that concept. Okay, so now let's just go ahead and open a slide that I've made for you guys to understand this. Right, here it is. So I've got some text written here, and you might be wondering what it is. So let me just explain myself. Here I've got two pieces of information. The left side motors, and under that I've got some information. And the right side motors, and under that I've got some information. Now, first, before we understand this, we need to understand what's the left of my car, what's the right of my car, what's the front, and what's the back. So let me show you guys what it is. So this is the front of my car, this is the right side of my car, this is the left side of my car, this is the back of my car. Now, once we've understood that, we can go ahead and understand what this is. Now, left side motors and right side motors. Now, I'm pretty sure you're all familiar with this because in my last tutorial, I showed you guys that instead of looking at our car like 4 different motors, we need to start looking at them like 2 different units. Unit 1 and Unit 2. Unit 1 as the left side and Unit 2 as the right side. Or you can go ahead and just call it left side and right side straight up. Now, I've just added motors to this because we're actually controlling the motors. So that's why I said left side motors and right side motors. Now we've got that out of the way, we can go ahead and look at what's the information under there. So you can see that I've put some numbers down and I've given them all some values, and forward and backward values. Now, if they're not just any old numbers, they're actually our pin numbers that we use to send outputs to the L29810 module. And if you remember, they're 7, 11, 13, and 15, and I've declared all of those here, and I've given all of them values of backward or forward. Now, today I'm not going to be talking about how to find these values out, backward and forward, which one's backward and which one's forward, or why we need to know these. But we are going to talk about how to use these values to send outputs to our L29810 module so we can control our car. Now let's look at how do we do that. So, we're going to be using the statements true and false to control our car. So true and false. So these are the 2 statements that we're going to use to control our car right here. Now I'm going to show you an example to just, get this into your brain. Right, so let's just say we want our left side motors to go forward and our right side motors to go backward, right? So what you would do normally is send a true signal to pin number 15 on the left side motors because we want our left side motors to go forward, and at the same time we would send a false signal to pin number 13 because we don't want our left side motors to go backward. Right? And on the right side, what we would do is send a true signal to pin number 7 because we want our right side motors to go backward, and a false signal to pin number 11 because we don't want our right side motors to go forward. So to represent these statements and this information and actually turn it all into command, I'm going to be showing you that command today. So the command we're going to be using to represent these statements and information is GPIO dot output open brackets, put in the pin number you're trying to control. So if you were sending a true signal to pin number 15 because you want your left side motors to go forward, you would put in pin number 15 because that's what you're sending a signal to, comma, a true or false statement. So if you send true, that action is going to happen, and if you send false, that action is not going to happen. Now we also need to understand that we can never leave a pin delayed, so we always have to send responses to the pin numbers. So once you've declared them in your setup, you would have to send a true or false signal to them. So if you want your left side motors to go forward, you would have to send a true signal to 15, but at the same time send a false signal to 13. And we also wanted our right side motors to go backward, right? So we would send a true signal to pin number 7 and a false signal to pin number 11. We need to combine both of these right side motors and left side motors pin numbers. So we would write 4 statements of the 4 lines of this code, of the same exact code, with some changes in the pin numbers and the true or false statements. So let's go back to our example, which is left side motors need to go forward. So we need to send a true signal to pin number 15 since it's forward and it's the left side, right? And now let's go back to what we need to send a false signal to. So we need to send a false signal to pin number 13 since it's backward and we don't want our left side motors to go backward. So we just send a false signal to them. All we need to do for that is type in GPIO dot output open brackets, declare whatever pin you're trying to control, which is 13 right now, comma, a true or false statement. Now we want it to be false because we don't want our left side motors to go backward, so we would put false and close the brackets, right? And this is not enough to make our left side motors to go forward. even if we didn't want our right side motors to even go any direction, we would still need to send a false signal to both of them, because as I said, once you declare them in your setup, you would have to send a response. So you would exactly put these two statements right here again and change those values to these right here. So you would put these down in your function, and after that, what you would do is do the exact same. So you would have 2 more lines of this code, and then what you would type in is, and then you would put down your right side pin numbers as well. So in your right side pin numbers, we wanted our right side motors to go backward, right? So we would automatically send a true signal to pin number 7 since it's backward, and a false signal to pin number 11 since it's forward, right? So let's go ahead and do that. So we put 7 here since it's backward and we want that to be true, and we put 11 here since it's forward and we don't want it to happen, so we put false beside it. So you would put the left side motors GPIO.output statements and the right side motors all the statements in one function, and that would be your function ready. But we have to add a little more statements to that, and I'll show you what are those in just a minute. So once you've understood this concept, we can now go ahead and go into our code and write this down. So let's start off nice and simple and make our all motors go forward. So we want our car to go forward. So we would write a function for forward, and then I would call my function after its action. So if I wanted my car to go forward, I would call the function forward. That's completely optional. Open brackets, close brackets, and colon. Now don't worry about any of this code. This is all going to be in GitHub, and I'll leave a link in the description below. And all we need to understand here is the logic, and it's all good. So under this, as I said, we need to type in our statements, which is GPIO.output, and open brackets, and declare whatever pin we're trying to control. And if you go back to our slide, we know that we want our car to go forward, and the pins we need to activate are pin number 15 and pin number 11. And we need to send false signals to pin number 7 and pin number 13. So it would look something like this. So you want your 15 to happen, so you would send a true signal to it and a false signal to pin number 13. A true signal to pin number 11, since it's forward as well, and a false signal to pin number 7 because it's backward. So that's all that would happen here. So let's go ahead and apply this to our code. Okay, so here we would declare pin number 7 first, comma, true or false. This is backward, so we would put false, and close. And we would just copy this line of code and paste it and make a few changes to the true or false statements. So let's go ahead and do that. And change these pin numbers to all our pin numbers. And we know that 11 is forward, so we send a true signal to this. And 13 is backward, so we send a false signal automatically. And 15 is forward, so we send a true signal to this. Okay, so now all we need to do is add 2 more lines of code and we're ready. And the first line of code that we need to add is, of course, calling the setup function under the forward function, because before we call any function and we can have any control over our car, first we need to call the setup function, since we need to set up our pins and everything first. So to call that, all I have to do is put that under my forward function, and I would call it like this, because that's how we call a function. And I called it under the forward function so that whenever I call the forward function, the setup would automatically run first, and then our controls for the car would run. Now, let's go ahead and call our function. So to call our function, all you would type is forward, open brackets and close brackets. Save this code first before we run it, because of course we need to save code before we run it, right? And I'm going to create a new folder on my desktop, and I'm going to call it Smart Car Control. And we can create that and name this file Basic Controls. and no spaces between files, so I'm just going to replace that with underscore and OK. And once you've got that saved, we can go ahead and run this code. As you can see, now our car is able to go forward because all my wheels can now spin forward. Let's go ahead and write functions to stop our car. To do that, all you need to type in is def and give your function a name. I want to call mine stop car because that's what it's doing. And open brackets, close brackets, and colon. And under this, we have to set all the pins to false so that no actions are taken. So none of our wheels are going to be spinning forward or backward. So to do that, we're still sending signals to the GPIO pins. So of course we still need to call the function setup like we did above. And under this, we can just copy this code right here and just replace the true statements with false. So I'm just going to go ahead and copy the false statements and paste them on trues. Okay, so that should be our stop car function ready. So when we do this, all our motors should stop, and to test that first we need to send like calling the function forward so all the motors can go forward, and then we can call the function stop car to see if the motors stop. So let's go ahead and call this function forward. So we've already got that written, so all we need to do is save this and run it. So let's run it. So as you can see, all my motors are spinning forward. Now I'm just going to call the function stop car to see if the car stops. So as you can see, my car stopped. And so we've successfully written functions for setup, forward, and stop car. But if you look at my console right here, like my shell, you can see that I've got some warnings. Let's go ahead and read what these warnings are all about. So these warnings are saying this channel is already in use, continuing anyway. So what it's saying is that this channel is already in use, so it's already in use, so you're continuing anyway. So it's not going to affect any of our code or anything, but we're creating more channels. To understand this warning, we need to first go ahead and understand how the Raspberry Pi communicates with the L29810 module using a channel, and then we can look at the solution to fix this warning problem. So let's go ahead and look at our slide I made here. So as you can see, I made a simple slide here for you guys. On this slide you can see I've got my Raspberry Pi, I've got my L29810 module, I've got some jumper cables attached to linking them both up like we originally did right here. You can see we've used some jumper cables to attach to the L29810 module's input pins, 5 volts, and the ground. Now, let me tell you that these jumper cables are not the one that transfer signals from one to each other. So the jumper cables are not the ones that send signals to the L29810 module's input pins to make the car go forward, backward, right, left, any kind of pivots, right? So any action is not sent by the jumper cables. It's sent by something called a channel. You must have seen that in the warning just a minute ago. Let me show you. Here you can see channel, right here. So that's what's used to send signals. Okay? So once we understand that, we can look at what is a channel and what it's used for. So a channel is used to send signals from one device to another device. So basically a link between one device to another device. Now most of the devices now in the world can do that wirelessly, but some can't. Or to be more particular, the smart devices, so the ones that have like Bluetooth, can connect to network, they can transmit signals wirelessly. But some don't, like the L29810 module. Now the Raspberry Pi is smart because it has its own CPU, it has its ways to send or transmit signals from one place to another, but the L29810 module doesn't. So we use some wires so that the Raspberry Pi can create a channel using the connection between the Raspberry Pi and the L29810 module, which is the jumper cables. So the channel is made through the jumper cables to send signals to the L29810 module. So the channel is the one that technically sends signals to the L29810 module from the Raspberry Pi. Now, once we've understood that, we can go ahead and look at these 3 questions on our left side right here to clarify any doubts. Right here you can see that my first question is how the Raspberry Pi sends signals to the L29810 module. Now we can answer that easily through a channel, right? And the second question is, if the Raspberry Pi sends signals through a channel, what are the jumper cables for? Now we've looked at this as well. The jumper cables are so that there's a connection between the L29810 module and the Raspberry Pi, so a channel can be created since the L29810 module is not smart. And the third one you can see says, what does the Raspberry Pi use to send signals to the L29810 module? It's the exact same question right above right here. So the answer is the same. Channel. So a channel is what is used to send signals to the L29810 module. Once we've understood that, we can take a look at how to solve the problem here, which is this channel is already in use and we don't want this warning, so let's look at how to fix this problem. Okay, so to fix this problem, all you need is 2 lines of code and your problem's fixed. So let's look at what are those 2 lines of code. So these right here are the 2 lines of code that will fix our problem. So let's look at this step by step. First, let's start off with gpio.cleanup. gpio.cleanup is a function from the GPIO library, and what it does, it clears the ports and the channel and whatever signals you send to the GPIO pins. So that's what the cleanup function does in the GPIO library. Now, this would help us fix our problem because what it does, it clears the channel, and all we need to fix our problem is something to clear our channel as soon as we executed our program. So this would do that. So you can just go ahead and put this at the end of your program and that warning will be fixed. But we would run into another problem. As soon as you execute the code, what would happen is you wouldn't even see an action. Right? No action will be given as an output, because what you're doing is you're sending signals to the ports, right? And straight after that you're sending a signal to clean up the channel, so you would not see an action. So to fix this, all we need to do is put time.sleep, and what this does, it delays the execution for 10 seconds. So meanwhile, in that 10 seconds you would see your action. And then after those 10 seconds, it would clean up. So this is how we fix our problem. So let's go ahead and apply this to our code. To do that, first we need to go back to our desktop and let's go ahead and apply our fix to this problem. So as we said, we need to put time.sleep at the end of this function, and remember I told you we need to import the library time. This is what I was talking about. So we put time.sleep, open brackets and close brackets, and we click enter, and under this we put gpio.cleanup. Okay. So once you put gpio.cleanup, your problem should be fixed for the forward function. So you can do the same for your stop car as well. So you just add these 2 lines of code and that should do it. Okay, so now just to make more automatic and more automation, so you would just declare a variable in this brackets of the time.sleep, and then what this does is you would need to declare it here, and the same variable in the forward functions bracket as well. So what would happen is whenever you're calling the function, you can just put this, how long you want your function to run inside the brackets of your function. So if I were to call forward, let me just put forward here and change it to capital. So if I was to call forward, all I would do is put 10, if I wanted my car to run for 10 seconds, I would put it in 10 seconds and my car would run for 10 seconds, right? So once we understand that, we can go ahead and run this code. Now, we need to understand that this code will still give us a warning as soon as we run this, because the channel has already been created and we are creating it one more time. So once this code is executed and we run it again, it should not show us a warning. So first let's clear the console and let's see if this code is going to work. So let's save it and we're going to run it. As you can see, my code is being executed and it's going to stop after 10 seconds. As you can see, my car stopped after 10 seconds. And this time I'm going to run it again, and what it should do is should not give me any warnings. So let's try it. As you can see, it didn't give me any warnings. So this is our problem fixed. So no matter how many times we run it now, it's not going to give us a warning. Let's change this to 5 seconds. Just 5 seconds to make it quicker, and we run this. As you can see, I ran it again and there was no warnings. So this is our problem now fixed. Now we've covered how to write functions to control our car. We've understood the concept of channels, and we've known how to fix the problem of giving the channel being created every time. So we learned how to fix that problem. Now it's so easy for us to go ahead and write all this code down. So let's go ahead and write a function for backward now. So let's look at what pins we need to send a true signal to and false. So pin number 13, it is backward and we want our car to go backward, so we would send a true signal to pin number 13. So let's go ahead and write that down. Okay, and now let's look at pin number 15. Pin number 15 is forward and we don't want any of our motors spinning forward, so we put false for this. Now let's look at pin number 7. We know that pin number 7 is backward and we want all our motors spinning backward, so we would put true for this. And now let's look at pin number 11. We know that pin number 11 is forward and we don't want any of our motors spinning forward, so we would put a false signal for this. Okay, so these are the true and false statements, and which pins we need to send a true signal to and which pins we need to send a false signal to make our car go backward. So let's go ahead and apply this to our code. So let's go back to the desktop, and here we can just go ahead and write another function to make our car go backward. So def, and you can call your function whatever you like. I'm going to call it backward. Open brackets, close brackets, and coulomb, and under this we can just call setup first, like we always have to call setup, because we need to set up our pins. And under this we can just copy this code right here and just replace some true or false statements. So all that is going on here is the exact opposite of backward, so we just need to change that. So we know that pin number 7 is backward, so we'd send a true signal to that, false signal to pin number 11 since it's forward, and we don't want any of our motors spinning backward. And 13 is backward as well, so we'd send a true signal to that, and a false signal to pin number 15 since it's forward. And that should be our code to control the car. And now all we need to do is apply the fix of not creating another channel every time. So time dot sleep, open brackets, close brackets, and under this GPIO dot cleanup. Okay, and in this we declare a variable. I'm going to declare the duration variable again. And we declare the same variable in backward. And that's our backward function ready. And let's go ahead and call this function and see if it works. So we put 5 seconds again and just change this for to backward. Okay, and that should be our backward function ready, and we've called it as well, so everything should work fine and all our motors should be spinning backward. So let's test it. As you can see, all my motors are spinning backward and they've spun for 5 seconds, and if I can put how long I want my motors to spin in my brackets right there. So we know that it's working, so we can go on to the next function now, which is a function for making my car go right. So to do this, I need to write another function. I'm going to call it right. Open brackets, close brackets, and cool. And under this, I have to call setup, like always. And let's go back to the slide to see which motors we need to send a true signal to and false signal to make our car go right. So first we need to understand, to make my car go right, my left side motors need to be spinning forward in this direction, and my right side motors should stop to make my car go right. So let me show you what's the action going on here. So it would go like this. Okay, so let's look at what pins we need to send a true signal to and what pins we need to send a false signal to. So we know that our left side motors need to go forward, so we would obviously send a true signal to pin number 15 since it's forward. So we send a true signal to that. And we would send a false signal to pin number 13 because it's backward and we don't want any of our motors spinning backward in this case. So let's send a false signal to pin number 13. And let's take a look at the right side motors now. We don't need any of the right side motors to even spin, so we would send a false signal to both of them. Okay, so this is the statements of true and false, and this shows us which motors we need to send a true signal to and which motors we need to send a false signal to. So let's go ahead and apply this to our code. Open my desktop and just write that under there. So I just need to copy this statements of backward right here and just change a couple true and false statements, and that should do it. So we know that every port except pin number 15 needs to be false. So let's go ahead and send a true signal to pin number 15 first and a false signal to the rest of them. Okay, so that should be our right side function ready, and all we need to do now is add time.sleep, open brackets, close brackets, and in this declare a variable and declare the same variable in my function's name. And we can put GPI.cleanup at the end of this to clear up the channel once it's done. Okay, so that should be our right side function ready. We can go ahead and call it to see if it works. Open the brackets and declare how many seconds I want my function to run. I want my function to run for 5 seconds. Now let's close the brackets and run this to see if it works. So first let's go ahead and save it and run it. As you can see, my left side motors are spinning forward and they spun for 5 seconds. That tells me that my right side function is working and my car can now take a right. So now let's go ahead and write a function for left now that we've written a function for right as well. So to write a function for left, all I need to type in is def left, open brackets, close brackets, and colon. And under this, I just need to copy all this right here and paste it underneath. And just change a couple true and false statements and we're ready. So to make my car go left, we need to understand that let me just go ahead and explain it right here. So my right side motors need to be spinning forward and my left side motors need to stop in order to make my car go left, like this. So let's go ahead and see if it works. So let's look at what pins we need to send a true signal to and what pins we need to send a false signal to. So we know that my left side motors need to not even work, so they need to be stopped, so we would send a false signal to both of their pins. So false and false. And we also know that we want our right side motors to spin forward, so we obviously want to send a false signal to pin number 7 since it's backward, and we don't want any of our motors spinning backward in this case as well. And we also need to send a true signal to pin number 11 since it's forward and we want our right side motors to go forward. So let's go ahead and apply this to our code. Right, so we know that every pin except pin number 11 needs to be false. So let's go ahead and make pin number 11 true first. And make every other pin false. And that should be our function ready for making my car go left. So let's go ahead and call this to see if it works. So under this, I'm just going to say left, open brackets, and declare how much time I want my left side function to run for. This time I want to run it for 7 seconds, and I'm going to close the brackets. And I'm going to run it to see if it's working. Okay, we've obviously done some kind of mistake here. So, what have we done here? Okay, so it is saying that, okay, so of course, we forgot to declare the variable in the function's name. So, the function's bracket. So now it should work. So we save this and run it. As you can see, my right side motors are running forward, and they're going to be running forward for 7 seconds, like I said. And we just done a little mistake there, and all that was that we did declare the variable in time.sleep, but we forgot to declare the variable in the left side function's brackets. So it thought that we didn't give it any argument, so why are we declaring our argument? So now we've written functions for forward, backward, right, left, stop car. All we have left is pivots. So let's go ahead and write functions for pivots. First, let's write a function for the right pivot. Okay, so all we need to type in is def, give your function a name for right pivot, and I'm going to call mine right pivot. Open brackets, close brackets, and colon. And under this, we need to first understand how to do a pivot. So to do a pivot, all that's ever going to happen is one side of the motors are spinning backward always, and one side of the motors are spinning forward always in order to do a pivot. So what a pivot does is the car stays still in its position, but it's taking a right or a left. So in order to do a right pivot, our left side motors need to be spinning forward, and our right side motors need to be spinning backward. So a way to remember it is that it's the exact same as right, but instead of stopping the right side motors, we're just making them spin backward. So we can just go ahead and copy the right side function's code in it, and just instead of making the right side motors stop, we can just make them spin backward. And let's go ahead and write what we need to do down in this slide. So in order to make my car do a right pivot, we need to send a true signal to pin number 15 because we need our left side motors to spin forward, so we send a true signal to that. And we also need to send a true signal to pin number 7 because we want our right side motors to spin backward. And we also need to send a false signal to pin number 13 because it's going to make our left side motor spin backward, which we don't want, so we want to send a false signal to it. And we also want to send a false signal to pin number 11, which is the right side motors, because we don't want the right side motors to spin forward. Okay, so this is the true and false statements to make my car to do a right pivot. So let's go ahead and apply this to our code. Let's go back to my desktop here. Okay. So in this, all we need to do is, instead of sending a false signal to pin number 11, pin number 7, we're just sending a true signal to pin number 7 because we want our right side motors to spin backward. And that should be it. That should be all for making my car go right pivot. So we just need to declare the variable in the functions brackets, and then we can declare the duration of how long we want our right pivot to happen. So I'm going to just call my function here right pivot, and I want this function to run for about 6 seconds. So I'm going to put 6 there. And what we're expecting here is my right side motors to spin backward and my left side motors to spin forward in order for an action like this. So my car can take a right pivot like this. So let's go ahead and run this, and my car should be able to do a right pivot for 6 seconds. As you can see, we're getting what we expected, and my car should stop right about now. As you can see, now we've wrote a function for right pivot. All we have left to do is write a function for left pivot, and we're done with the basic controls. So let's go ahead and write a function for left pivot. So all we need to do for that is write in def, name for your function. I'm going to call mine left pivot, open brackets, close brackets, and I'm just going to write duration here first because I know that I'm going to have a variable like that. So all I have to do is just copy the code for the left and just paste it under there, and we can take a look at what pins we need to send true or false signals to. So let's go back to our slide right here. So let me just clear it here. So in order to make my car do a left pivot, we first need to understand that to make my car do a left pivot, I need my right side motors to spin forward and my left side motors to spin backward. So we have an action like this to make my car do a left pivot, to go like this. So all we need to do here is send a true signal. Let me just draw all these arrows here. As I was saying, send a true signal to pin number 13 because we want our left side motors to spin backward. And a false signal to pin number 15 because we don't want our left side motors spinning forward. So we said false. And send a true signal to pin number 11 because we want our right side motors to spin forward. Sorry, I just put that in red, not to get you confused. So true signal to pin number 11 and a false signal to pin number 7 because it's backward and we don't want our right side motor spinning backward. So this is the code we need to make our car do a left pivot. So let's go ahead and apply this to our code here. So all we need to do here is, instead of sending a false signal to both the left side motors, we just need to activate. So we just need to send a true signal to pin number 13 and we're ready. And that should do it. And then all we need to do is change this right to left. So let me just say left here. And I want my left pivot function to run for about 10 seconds. So I'll put 10 there. And this time I'm going to run it, and all we're expecting here is my right side motors to spin forward and my left side motors to spin backward in order to make my car do a left pivot. So let's go ahead and save this and run it. Okay, we obviously done a mistake here. Okay, we forgot to put a coolum after this. Okay, so once we've got that fixed, we can go ahead and save this code and run it. As you can see, my right side motors are spinning forward and my left side motors are spinning backward in order to make my car do a left pivot. Okay, now it's stopped because it's been 10 seconds. So guys, that's it for this tutorial, and in the next tutorial we're going to be looking at how to control our car through a web application. And in this tutorial what we've learned is the basic controls of how signals go from our Raspberry Pi to our L29010 module, and the code for sending signals to our L29010 module.